Welcome to the Real Python Podcast. This is episode 104. Do you understand how a hash table works? What if you could learn about building one while practicing test-driven development? What are best practices when designing a REST API? This week on the show, Christopher Trudeau is here, and he's brought another batch of PyCoder's weekly articles and projects. We talk about a recent Real Python article titled Build a Hash Table in Python with TDD. The tutorial shows how to implement a hash table prototype from scratch in Python. It also provides a hands-on crash course in test-driven development. Christopher shares an article on designing REST APIs and provides some of his own best practices. We cover implementing authentication, good naming conventions, versioned APIs, and how to specify dates. We cover several other articles and projects from the Python community, including a news roundup, removing dead batteries from the standard library, comparing the Python list versus tuple, how to write user-friendly CLIs in Python, just enough Cython to be useful, a cross-platform TUI and ASCII animation package, and running Black on Python code blocks and documentation files. This episode is brought to you by Anvil. With Anvil, you can create web applications entirely in Python and deploy them on the web. You don't need any web development experience. Start building Python web apps for free at anvil.works. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Mr. Bailey, good to see you. Or hear you, yes.
Yeah, we haven't been doing the video thing yet.
For the sake of our listeners, that's probably a good thing.
Yeah, we were going to start off with some news again. Between PEPs and Python releases, I think we got plenty of news to cover.
For sure. So I'm going to start off talking about PEP 594. Python refers to itself as the batteries included language, meaning you get lots of the stuff in the standard library. More common now with a lot of languages, but when Python first came out, this was not as typical. And having everything built in was sort of a benefit of going to the language. Of course, the problem is one person's everything is another person's clutter. And every package in the standard library has got to be maintained. It makes it, the more stuff you have, the harder it is to fit it into small devices. And in some cases, you've got duplication of functionality as things have grown and changed over the years. So once in a while, you got to do a little bit of house cleaning. And PEP 594, called Removing Dead Batteries from the Standard Library, is, well, it's springtime, and we're going to dive into that kitchen drawer filled with old cords and dead batteries and tidy up a bit. As with most PEPs in the news, this one's been kicking around for a couple of years, but the reason it's popped up on the radar is because the work is being done in the 3.11 alpha release. So the PEP's been around for a while, but now we're doing the work. So what's in the drawer that's getting cleaned up? There's a bunch of audio libraries for formats that were kicking around when grunge was popular, several of which I had never heard of. There were some CGI libraries, which made me feel old. That's web stuff back from the dark ages. And then there was some cryptography things that are old and basically almost historic, dinosaurs and easy to break. A couple of asynchronous tools that async.io, now that it exists, we don't really need the originals. And then there's some other odds and ends. So all told, there are 21 libraries scheduled for removal. I've been writing Python for a little over a decade now. I've only ever come across 2 of them. So these aren't big popular things. About half of the 21 libraries have direct replacements, either stuff already in the standard libraries or packages out there that take care of the same thing. 19 of the 21 are going to be fully removed in 3.13, so they're being deprecated in 3.11. And the 2 async libraries are going to get out the door just a little earlier in 3.12.
Great.
For the most part, this will affect very, very few people because, the reason they've been identified to be cleaned up is they aren't really getting used much anymore.
Yeah, I think we've discussed it when I had Brett on the show, and he was talking about kind of going through and the idea of sort of combing the library. I guess Wuka's talked about it too, and seeing what's been touched, what's been updated, outside of just like formatting changes or other stylistic changes that where something maybe got caught up in a update across several things. But yeah, I think it's good. You got to do that, especially if you're going to have a batteries included type of language. You probably are going to need to keep an eye on those things,
particularly with the duplicates, right? Because that just is confusing.
Yeah,
when there's three ways of doing something, part of the zen of Python is there's only supposed to be one way, right?
Yeah.
So as a newbie coming to a library, you start looking for something, and you're like, oh, there's this one or that one. Which one am I supposed to use?
This one's kind of a fun roller coaster of a set of things. On March 16th, Python 3.10.3, 3.9.11, 3.8.13, and 3.7.13 were available. And lots of updates as far as security content for these updated Python versions. And they last time they were start this paragraph with, last time around I was complaining about cursed releases, which ends up being kind of this theme, because maybe I should talk about the updates generally. There were, in this 3.10.3, there were like 220 commits since 3.10.2, so large amounts of bug fix stuff going on in there. You can kind of check out the logs there. The other updates in 3.9.11 had some of the same kind of stuff happening in them. 163 commits in that one. The other ones, 3.8 and 3.7, those updates were mostly kind of geared towards security, just the state that both of those are in. You might note that 3.6 is not included there. They mentioned there Python 3.6 is pining for the fjords. Python 3.6 is no more. It's an ex-Python. It has ceased to be. So anyway, some Monty Python humor there. Yeah, it reached its end of life December 23rd, 2021, which is interesting because that's like 3.6 is definitely the one that where I really started using Python. So it's kind of interesting to think about. But then on the 24th, there was this tweet from Łukasz Langa, and it was 3.10.4 and 3.9.12 are now available out of schedule. So shortly after releasing them, like literally under a week, they had identified a regression that caused Python to not build properly on Red Hat Linux 6. And their new release addressed that. And so again, diving deeper into the whole cursed releases thing happening there. They note that even though it's an 11-year-old version that is now out of maintenance support, it's still used in a lot of production workloads. And, some of those rely on 3.9 and 3.10. And in particular, they have their own Many Linux 2010 image that's used to build widely compatible Linux wheels based on CentOS 6. They've been feeling this kind of curse of like having to do multiple releases as they go. The hope is to not see any new releases or changes until May, hopefully, when they have their next regularly scheduled bug fixes. But yeah, I have a long talk coming up next week with Pablo, and we talk a little bit about being release manager. And so this is kind of some timely news of the kind of stuff that he's having to work through. And obviously, Łukasz has been on the show a couple times, and both of them have been working not only on 3.8 and 3.9, but 3.10, and like I said, the alpha releases for 3.11. There's a lot kind of coming in there, and we talk a lot about the improved error messages, so I'm very excited to share that episode coming up soon. On other news, I have an event that's coming up, EuroPython 2022. The ticket sales are now open. They started on March 17th, and EuroPython is going to be held from July 11th through the 17th. It's both in person and virtual, and it's going to be held in Dublin, Ireland. So if you're interested, they had this little quote, and having talked to several conference organizers, I can feel their pain with this. They have this little like comment: planning a conference is easy and stress-free, said no organizer ever. I am planning on going to PyCon US. I'm excited to see everybody there. I know a lot of people in the Python community already have been talking about meeting up there. So there'll definitely be a real Python contingent as long as everything goes smoothly from this point forward. So that moves us into articles. I think you had the first one.
Yeah, so this is the list versus tuple, a in-depth comparison. This is an article by Cython Ambi. He does a lot of writing for both Python and machine learning. As the title implies, the article goes over the similarities and differences between lists and tuples in Python. So he starts out by describing what's the same. So they're both sequences. They both support storage of heterogeneous data, which means you can put different kinds of stuff in them in the same sequence, which is different from a lot of languages. A lot of languages don't let you do that. And both lists and tuples support a bunch of operations in common, like concatenation, indexing, slicing, min, max, length, that kind of stuff. So the first big difference that he talks about is that lists are mutable, whereas tuples are not. So you can change the contents of a list, but if you attempt to do that with a tuple, you're going to get an exception. This is kind of why tuples exist. There are underlying optimizations you can do with immutable objects. So spoiler alert, you're likely to get some performance improvements if you go down that path. So lists being mutable means they have more methods on them. They come with methods for adding and removing things from the list, which makes sense. The first performance advantage that I hinted at earlier is storage. Lists over-allocate memory, so they don't have to get a new chunk of memory every time you insert something. This, of course, means your list is taking up more space than you might think, and that can compound with large data sets. A simple example that he highlights in the article is that under his setup, an empty list takes up 56 bytes, and adding an 8-byte number to that list actually causes the list size to go up by 32 bytes. Adding the next couple of numbers actually doesn't change the list size, and then it hops up again, so it's going up in chunks. Measuring this can get complicated because how it is allocated is different based on whether you're starting out with an empty list and appending or starting out with a list with stuff in it. You can get different memory usage out of those two cases. So tuples, by contrast, are allocated based on the size of what's in them.
Okay.
In Chetan's case, an empty tuple was 40 bytes, which is 16 bytes smaller than the list empty. But a tuple with one more integer is exactly the same. It's one more integer larger. Of course, you can't append to a tuple, so he's actually comparing different tuples. The other performance piece that he talks about is the difference in creation time. He uses time.it to track a bunch of things. You end up with almost 6 times performance improvement of tuples versus lists at the creation space. And access time tuples are better as well, although that's like a 3 or 4% difference. Then the article goes into a little bit of an explanation as to what the compiler generates and where these performance improvements comes from. So it's a decent read, and if you like delving into the deeper stuff here, there's some good details in it.
Nice, yeah. So my first article dives into command line interfaces, which I think we talked a little bit about on the show kind of off and on. But after the point that you've created a very simple Python program, first off, running a script, if you would like other users to get something out of this program, maybe you would like them to be able to have some flexibility, this is probably your next step, is to think about how could you create a command line interface where people can put in additional values or put in different parameters, or maybe it's something that's addressing files. You want to have them be able to put in a file path and so forth. And you're not quite ready to learn a graphical user interface or even a text user interface. This is an article by Xiaoshu Gao. It's from Towards Data Science, which we've mentioned several times on the show. It's a Medium blog. It's titled How to Write User-Friendly CLIs in Python. It actually covers 5 of them, which I think is really neat. 5 different sort of libraries or methodologies that you can use to kind of break into it. And I'll share some additional resources as they went. One of the quotes is, if you want your user to configure your program, then think about creating a CLI. And then she references an article that I hadn't heard of. It's a sort of an open source guide written by a collection of people called Command Line Interface Guidelines. And it's clig.dev is the web address for it. I was really impressed with that document. There's a lot of good information. It's similar to something that we're going to have a discussion later about, where it's sort of, giving you general advice that's sort of agnostic as far as like, it's not specifically for Python, although there are some advice as far as libraries that they like in Python that follow some of these guidelines. In pulling things out of that set of guidelines, she mentions 3 different aspects. The first is you would like it to be easy to discover how your command line interface works, having help text, examples and suggestions when there's an error. It should be robust. It should expect the unexpected, if you will, that users may not understand how it's supposed to be run. And so giving errors that are not sort of scary, that go beyond syntax error or type error or something like that can give you a little more information that they can be graceful and not scary. And then provide the right amount of information kind of coming back once the things run to the user. And so throughout the article, they build a simple QR code generator. It's sort of fictitious in the sense that it's not a true COVID vaccine QR code. And the main program uses data classes, which are great for this type of information where you're like, okay, I want to provide the name, the date of birth, manufacturer, and the dates that the different vaccines were given. The first one that she uses is argparse, which is part of the standard library. And actually, she references a EuroPython article on it, which was by David Mastro Mateo. It's titled How to Build Command Line Interfaces in Python with argparse. And it goes really in depth, much deeper than this article does, about all the different parameters and laying them out. But she goes through argparse, and it's a good library to get started with, to kind of get the inner workings of everything and kind of see what are the types of things that you might provide and kind of work through. In some ways, it's not the prettiest library or the most sort of developer friendly of them. And those are sort of the aspects that she points to kind of going through it. The article is nice because she does actually give graphical examples of like, okay, well, this is like the help that's generated from it. And then this is what it would look like use on the command line, what some different errors might look like. The next one is using a library called Click, which uses decorators. And I like this one a lot. It looks really clean. It's, in my opinion, a little bit more developer friendly in how that things are formatted in it. It is one that's covered in a course I'm going to talk about here in a second. The help message, I think, is a little nicer looking. And again, each one of them, she provides all these different kind of resources as to like, okay, what's this going to look like? What's the prompt going to look like? And so forth. Going beyond Click goes into one called Typer, which sort of stands on the shoulders of Click, is how she states it. It leverages type checking for configuring and validation of the arguments. So this one goes a little further. In this case, it's going to, in some ways, I think, be a little more secure because it has that type checking going into it to make sure that the users are entering the correct types of information into it. And then the last two are kind of interesting. One is called doc-opt, which uses a very different approach. Almost all of the setup for what your parameters are and potential arguments and help file and all that sort of stuff is done through a doc string. It's really rigid. You got to really know how to lay that stuff out. So it's not quite as flexible as other solutions, but it is popular. If you're kind of more of a documentation style developer and kind of think that stuff first, maybe that would be a good way to approach it. And the last one is one that I had not heard of, which is called Fire, and it's from Google. It is a lot more flexible. What I mean by that is that it doesn't require just like a function to be defined to go into this. It can also generate a CLI based out of the information from a class or a module or a dictionary or a list. This article doesn't go into examples of those things, but I think that you could probably learn quite a bit kind of going through their documentation and diving into it. Of the examples, it is the shortest code-wise. It is pretty quick to get in and out of. I think you can learn a ton just kind of practicing with some of these CLIs. argparse, I think, might be a good, again, starting library. I'm kind of learning some of the basics, and it's the one that's not going to require anything to be pip installed to kind of work with it. If you would like to learn a lot more, I'll probably feature this as the video course spotlight this week. But there's a EuroPython video course called Command Line Interfaces in Python. It's by Liam Pulsifer. It's a really great deep dive into using all these different features, and it goes into several of those additional libraries also. So yeah, lots of stuff to kind of practice working. We always talk about building projects here at EuroPython. Command line interfaces is one of those great resources where you can, again, build something that you can share with others, and they can kind of use your code as opposed to just simply running it. They can have a little bit of interaction with it through the command line. Have you used any of these other libraries, Christopher?
So I generally tend to use argparse when I need to solve these kinds of problems. Part of that is just because it's the one that's always there.
Yeah.
And part of that is because Django commands hook into it as well. So if I'm doing any Django coding, I kind of have to know it either way. I've maintained some other people's code who have used Click in the past. So I kind of have had a glancing familiarity with it, but those are the only two that I've actually used myself.
Nice. Yeah, a few of the libraries we talk about all the time, I think, use Click. I think Black uses it. I know some of the other libraries that are out there definitely go beyond argparse and try out some of these other solutions. So that might be something you run across as you look at the code from other libraries that are out there. What if you could create and deploy web applications with Python and nothing but Python? With Anvil, you don't need to be a web developer to start building powerful web apps. Just go to anvil.works and open Anvil's free online editor. Build your user interface visually with drag and drop components. Write your app's code entirely in Python using all your favorite packages. Then deploy it on the web instantly, or install the open source framework and host it yourself. Start building your first app today at anvil.works. So what do you got next?
So I'm going to start with this week's EuroPython article. It's by frequent contributor Bartosz Zaczynski. He's one of the more in-depth EuroPython guys. He always really gets deep into his coverage with stuff. So this is titled Build a Hash Table in Python with TDD. If you're not familiar, a hash table is a data structure used to map keys to values, and you want to be able to use it to sort of quickly access the values based on the key. And this is where you're going, isn't that a dictionary? Well, yeah, pretty much. So there's a subtle difference. You can implement a dictionary in other ways than a hash table. So dictionaries in theory are the purer concept, but most people are just going to use the terms interchangeably. And hash tables, which are also known as hash maps, are the way the dictionary is implemented in Python. So this is sort of a glimpse into the underlying part. So the hash part of hash table or hash map is about a algorithm that translates a piece of data, any data usually, into a small representation, and that's usually a string. And that's used for mapping the keys to the values inside of the data structure. So a simple example of this, which would be a lousy hash, is the size of the thing being hashed in bytes. So if you could take anything, put it in it, and then the hash version of it would be the, how many bytes it was. So your hash map then takes that and uses that as part of the lookup tool when it's storing things to get to the value. And this is how you can go from, using a giant string as your key and mapping to a value fairly quickly. Now, if you want to do fast lookup, something that can be helpful when you're writing the algorithm that does this is to have your hash values all end up being the exact same size. And if you do that, it allows you to store them in memory in order, which allows you to sort of treat it like an array, and then you can move around in memory quickly. And this is typically how it's done inside of hash table. One of the batteries that are still included in Python is a function that calculates the hash of an object. Actually, Python has two of them, one for a general case and a second one that's used in cryptographic cases. Hashes are also useful when storing passwords and other things. And the crypto version's a bit slower, but has better random properties, which make it more secure. So that's the basic idea. And that's about the first 15-20% of the article. The rest of it does something clever. It teaches you test-driven development at the same time as teaching you how to write hashes and hash maps. TDD is the idea of writing tests before writing code to make sure that your code passes your tests. It's a pretty decent coding habit to have. So you're kind of gaining some practical coding experience while mucking around and understanding your own hash map. So the rest of the article talks about the tests and the code that you need to write all the basic CRUD operations on your hash map. So CRUD, that's capital CRUD, which stands for create, read, update, and delete. And it's just so much fun to say CRUD. So Bartosz sort of walks through the handling of collisions. So that's what happens when you have two different objects that end up hashing to the same thing, and then starts talking about things like even the performance characteristics and what to do about them inside of your hash table. So there's lots to learn here. Like I said, I love using the whole TDD thing while exploring the hash table. So it's always good to use best coding practices, even if you're just playing around. So you kind of get this practical stance on something while you're learning some deeper computer science kind of concepts.
Yeah, it's nice to attack two things at once and get a little more practice in test-driven development. Some of these deep dives go really far into this stuff.
A lot of programming articles you come across in Python are, how to do X in Python, how to do Y in Python. This is really a computer science article that happens to be using Python. So like if you're taking a computer science or computer engineering course, often you'll have to learn how to implement a hash map. Nobody does it because everyone just uses libraries, but in order to understand how the data structures work, implementing them are a good way to learn that. So this article kind of goes along that kind of path while staying inside of the Python world.
Yeah, any of those kind of resources where you can kind of dive a little deeper, hopefully make it a little more approachable, along with not just being theoretical, you're actually kind of doing some of the building, even though it may not be something that you're looking at releasing, that you're learning the concepts behind them and diving into it.
Well, and this kind of stuff often tends to make you a better programmer, not because you necessarily have to know this to pass some test, but if you have a better understanding of how these kinds of data structures work, then you have a better capability of knowing when to use them and what their limitations are and what that looks like, right? So, an example in the hash map world is memory allocation. Again, kind of like that list thing we were talking about earlier, tends to happen in chunks. You go along for a while, and then all of a sudden there's this hit that can be a performance hit. And so if you know when that is and how that happens, then you can write better optimized code to understand the consequences of what you're asking your system to do.
Yeah, cool. So my next one is an interesting one. We've kind of bounced around this idea, everybody mentions from time to time the potential, like, oh, how can I speed up Python and what are the things that I can do? And we had a long conversation about the just-in-time compiling JIT of something like Pigeon, where I was talking with Anthony Shaw about that. This one is about a library that I've heard mentioned multiple times, and I wasn't familiar really with how it sort of functioned and how it was different. And it's one called Cython. So not CPython, but actually Cython. The title is an introduction to just enough Cython to be useful. It's by Peter Baumgartner. His blog is the same name. It's just peterbaumgartner.com. He's working at a company called Explosion, and he really just wanted to learn a little bit more about Cython. And one of the reasons is he was looking at the code base for a very popular library called SPACY, SPACY, which is, I'll take it from their website, an industrial strength natural language processing library. One of their quotes on their site is also blazing fast, excels at large scale information extraction tasks. It's written from the ground up, carefully memory managed Cython. And what he noted was that it's like about 16% of SPACY's code base is written in Cython. You might wonder, how is that helping and what is it doing and why this small percentage is making such a difference? And that's really where this short introduction to Cython, I think, excels. It's a good way to kind of give you an idea what's going on. He goes through 3 major steps to get there, to get these results. And at each one of them, you could potentially stop and say, okay, that's enough. I'm getting enough out of this. And so the first one was, if you're willing to add a compilation step of actually having to compile your code, you can get about a 2 to 3 times speed up of your existing Python only code. So instead of like a just-in-time compiler thing like we were talking about with Anthony, in this case, you actually have to take a separate step and run. And in that case, it's going to export out this .so file that is now a Cython file versus it being pure Python. And so that one's pretty easy. You're not really changing anything about the code outside of pip installing this and then running this compilation step. The second step requires a lot more. And he jokes that now that types are cool, and I know that is not always true in the case of some of my particular guest hosts.
Types will never be cool
in Python, but a lot more people are using them, and we've had a lot more discussions about them over time. But if you're willing to add types to the variables and functions in your code, you can get about a 10 times speed up. It's interesting how you do it, and the article goes through that. He had gotten a book to kind of go through it, but I think you could probably use this article plus the actual, and I'll include a link to the documentation page for Cython itself. You can learn quite a bit from there. you define these things in front of them, which I think is actually much more C style in general. It's like, okay, this is an int is what this next variable is going to be, and define what the functions are going to be. It's interesting language. It still looks like Python, but it adds these kind of types in a very unique place. So that one can get up to about 10 times speed up. The third step would be, okay, now maybe profile the code, look at it a little bit more, and do some computer science kind of thinking about this. And you can get approaching 50 times or more speed up. Again, you may not do this for your whole code. It may be just a portion of your code that from the profile as you run it and look at it, what is the slow path in your own program. So he uses an example, and this is kind of fun because we went through this together, me and Gerarna, about the 2021 advent of code. He uses the first problem and his simple solution in the sense that it's only like, I think it's less than 10 lines. He goes through these steps. He pip installs Cython. He makes a copy of his .py file into a pyx extension is basically all that he's changed. You define the compilation in a setup.py file, and you basically compile it by running Python, setup.py, build. Like there's a flag of in place that rewrites it, and it creates this .so file. That, just by doing that, sped up 2.2x on his 9-line Python file. Then he added the C types, defined, there's the cpdef that defines a function in front of it, basically a C function with Python syntax, and then added a couple C defs, which are defining integers or chars or things like unsigned, long, and float, some of these C different variants of types. That speed up, just adding those things, got him to 11.3 times from before, which is pretty huge. And again, not too much work. He said he spent more time kind of reading the documentation and kind of figuring out how to kind of lay all this stuff out. But the big one, to accomplish that one, I won't spoil it, but you can definitely dive through the article and learn much more about this if you're interested. But it really requires a lot more thinking. And there is a profiler sort of built into the Cython that you can add this flag as you go to compile that says annotate. If you flip that to true, it will output a highlighted HTML sort of report and highlights which code is which, where is it running Python, and maybe going down a slightly slower path. And so his whole last section is titled The Final Optimization, NumPy Arrays, Memory Views. And you can really dive much deeper into it, but he was able to do, again, a couple little minor changes. It's not much longer as code, but it was now running 86 times faster. So I don't suggest this for anybody, like you have to do this. But if you have a bottleneck of some kind, or you are wondering why your code runs slow in a particular process and have wondered about maybe optimizing it, this is another choice. And I've heard the name Cython around for a long time, and this is my first chance to kind of dig into it a little bit and learn a little more about it. As far as profilers go and wanting to learn more about your code and running it, Gerarna did an article a little while ago, and he just updated it. It's a Python timer functions, 3 ways to monitor your code. That's a real Python article. I'll include a link to it. In the last section of it, he includes C profile, and then about 5 others in the resources sections that you can go in and look at other ways of not only just running, time it and, timing your code, but also profiling the memory and kind of looking at your code and kind of seeing what's going on. So maybe that could be a good jumping off point for you if you're interested to kind of just see what's happening with your code. I think a lot of people are just happy to have their code run. And I think a lot of people program in Python because the programming step is so much quicker for them. Again, some of the things that we talked about of being a dynamic language. And so this is definitely a much deeper dive. And again, you can get some easy wins with it. But if you would like to get some of those speed ups, you can see maybe why they might replace 16% of their code with Cython for a big library like Spacey. So anyway, it's a neat article.
A few episodes back, we were talking about that optimization deep dive. The gentleman was, he did a whole bunch of different things to his Python code and got in the end result was hundreds of times speed up.
Yeah.
And for large data munching type stuff, this is really, really important. And one of the things that he talked about in the article was writing a C plugin for some of the harder to optimize places. Cython, I think, provides this nice little middle ground because it's essentially doing that, but it's doing it for you without you having to pull out your C compiler. And so you can get some of that benefit while still staying fairly much inside of the Python space. And, kidding aside, this is a perfect use of type hints, right? What you're doing is giving the compiler enough information that it can go and optimize based on that information. And, it can make a big difference for your speed up. And like you said, one of the reasons I like Python is because oftentimes speed is not important, and that's okay. There's a reasonable trade-off for how do I write better code and how do I maintain that code. But there are use cases where you need that speed, and tools like Cython can help you get that.
Yeah, and we've mentioned several of them, and they're working on making the language faster. I talked to Pablo about that also, but it's in general. I think one of the biggest advantages is the speed of writing it is, one of the reasons that so many of us like Python is that we can kind of iterate and build up something and create it. And then, if there's time, what is it? The premature optimization, sort of the fallacy there of trying to do it too early, it's like, but at a certain point, there are ways to look at your code again. And there's lots of resources out there if you'd like to speed stuff up, if you're willing to do a little legwork. So.
One of the wonderful things about our industry is if you don't like the speed your software is running, wait 2 years and buy a better processor. You might be astonished. It might be far easier than optimizing your code. So
yeah, true.
Throw more hardware at it.
This week, I want to shine a spotlight on another EuroPython video course. It dives deeper into one of the main topics this week. It's titled Command Line Interfaces in Python. It's based on a EuroPython article by Andre Burgot, and in the course, instructor Liam Pulsifer explains the details behind implementing your own command line interfaces in Python. You'll learn about the origins of Python command line arguments, the built-in support for CLIs in Python, the standards behind designing a CLI, and how to manually customize and handle arguments. You'll learn about several libraries available in Python to ease your development of a complex CLI, including the libraries argparse, getup, click, and prompt toolkit. I think it's a worthy investment of your time to learn how to implement your own command line interface and how to handle a variety of arguments to make them flexible and more useful to the users of your Python projects. Like most of the video courses on EuroPython, the course is broken into easily consumable sections. You get code examples for the techniques shown, and all courses have a transcript including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. Our discussion this week is more of an article this time, but it's similar in some ways to the command line interface resource that I provided, where a bunch of people got together and wrote, here are some suggestions on how you should approach this. So why don't we dig into what we're going to cover?
Sure. So this is by Ronald Blumpf, and it's called How to Design Better REST APIs. It's a language agnostic article, so it's nothing Python specific, but we're not going to hold that against him.
Yeah.
So REST is for remote CRUD operations. I got to say it again.
Yay!
So essentially it uses HTTP methods to fetch from a server or send modification requests to the server. It's kind of an interesting protocol. It's a non-standard standard. So compared to something like SOAP, which serves a lot of the same purposes, REST is much more loosely defined. And this is done on purpose. It allows you a degree of flexibility. For example, if you want to use JSON or XML as your payload, that's up to you. So the downside of that, of course, is from place to place and from API to API, you're going to find variations in how things are done. And Ronald's article essentially talks about the best practices when it comes to doing REST and allowing you to write better of these kinds of interfaces. So the main idea behind REST is to use the URL to define the object that you're fetching or manipulating, and then you use the HTTP method to determine the action. So if I want to get all of the user objects from my server, my URL is probably going to be something like /users, and my HTTP method will be get.
Yeah.
And then the URL can contain attribute information. So to be more specific, if I have the same example and I want to get a certain user, the URL might be /users/42, and then I'd be getting the user with the ID of 42. And if I want to edit that same user, I would use the exact same URL, but instead of doing a get, I use HTTP patch, and I send a payload that has the fields that I want to change for that user, updating them on the server. So that's the main idea. And Ronald's got a bunch of recommendations when you're trying to define what these endpoints look like. His first recommendation is to be consistent. So use a naming style for all of your objects that are the same so that people aren't having to look things up. He recommends snake case, and as do I, and I'm a Python guy, so that shouldn't really be a surprise. He talks about also making sure things like the resource names are consistent as well. So, for example, always use plurals or always use singular. Tend to prefer plurals. So if you've got users and user, and the developer has to look up which plural or singular you're using in what case, it's easier just to be consistent.
Yeah, that makes sense.
The second recommendation is about dates. Always use the ISO 8601 format. So that's the one that starts out with years and the months and dates. And always use UTC time zone. Time zones and localized date representations are going to cause someone problems somewhere. So he says just essentially avoid it. Let people do that on their side after using the API. The next one he talks about this. It took me a second to kind of grasp what he was getting at here, but then the penny dropped. So he says essentially you want to write your code so that authentication being required is the default. So when you write the endpoint, if you don't want authentication, write more code. Explicitly say, I want to turn it off.
Interesting. Okay.
And essentially the idea here is this stops you from accidentally exposing something that was supposed to require authentication.
Yeah, everything should be,
And this was one of my complaints about the Django REST framework, which did a course on a while back. The permission stuff in it is very slippery. And if you don't set it properly, it just exposes the URL you created, and you may not have meant to do that.
Do you know of a way to flip it?
I don't actually. I keep meaning to, there's a couple other toolkits out there that are trying to be replacements for DRF. One of them is Ninja, and it's on my to-do list to go read and see whether or not they fix that. Because I found that one to be particularly, you know my favorite foot gun analogy. You're going to miss toes if you're not careful.
You could say you're leaving everything exposed.
Yes, yeah, exactly. Is really what it comes down to. So, next one he talks about is a health check endpoint, and this essentially is just have a URL, usually something like /health, that just returns back a 200. So this is good for, like, see if the server is alive.
Yeah.
And oftentimes when you're doing complicated deployments, you're going to end up with things like load balancers that are trying to figure out whether or not your server's up. And if you have this, then it's a nice little URL that puts no load on your back end, instead of, say, putting in something that goes and requests data to check the same thing. Yeah. So this is an easy little thing. And then the other one that I'm going to talk about is the fifth recommendation talks about versioned APIs. This is the idea of including a version number in your URL. So that example I was using before, /users, should be something like /v1/users. And the reason for doing this is so that you can make breaking changes explicit. So you can add things to an existing version, but if you need to make a breaking change, you can change the version number as well, which means the URL will be different.
Yeah.
So this stops the confusion of someone calling your URL with out-of-date expectations. In production, this can be really, really useful at scale. So it allows your API teams to quickly publish new things while still maintaining the older ones for a while and deprecating them. So other teams can use your API, and they have time to catch up with the changes because they can keep using version 1 if they don't need the change from version 2. So you can make changes to support the team that needs the new feature, but without having to make everybody rush around and try to catch up.
Do you think a lot of other sites are using that?
This is a common thing in industrial scale APIs.
Okay.
So it's been a while, but I did some work with Facebook's Graph API probably 6 or 7 years ago. and they had it in there. And as an example, they gave about 18 months notice, I think it was, before turning version 1 off. And it's a long time period in that case because it was a public facing API. So you don't want to force everybody who's built a widget on top of Facebook to have to go, tomorrow it's not going to work. You want to give them time. So this version idea allows you, you need the new feature? Go use version 2.
Okay.
They're probably up to 6 or 7 by now. I suspect it was long enough ago. But it's a good way of sort of controlling these things, and it's one of the things I tend to recommend to my clients when we start talking about this kind of stuff. And there's weird little side effects of this as well, is it can help the interactions between your teams, because when you've got a larger organization, you're trying to coordinate these kinds of changes. Well, if you've got versioned APIs, you don't have to coordinate the changes, or you can put more time in between. So although it's a programming trick, it can actually make a big difference from the process methodology of creating new code inside of your organization. So I find that one's pretty useful.
Yeah, that makes sense.
There are 10 other recommendations in here. I'm not going to go into them all.
Yeah.
But they're all good stuff, and it's good practices. And I usually with this kind of article, there's almost always some place where I'm like, oh, no, don't do that. But Ronald's my kind of REST coder. All 15, I'm like, yep, got it. Perfect. Good. So so it was a good little jaunt. And like I said, not Python specific, but I still like Ronald. That's fine.
Yeah. We have a upcoming course on Fast API. It was kind of fun watching that and kind of comparing it to what you were doing in your DRF, Django REST framework one. And the idea of he mentions also returning the resource when you're posting and referring patch over put. And some of those I could see being included and why these are best practices. And it's a good resource. And I wonder if you have other horror stories of these kinds of things going awry.
The permission one really is the one that gets me, because you got to be really, really careful with that kind of stuff, because it's the kind of thing that's really hard to catch. You get it out into production, and then you find out months later that, okay, we've had a live thing that wasn't supposed to be, and how much have we leaked? There's no way of knowing it. These kinds of interfaces are becoming increasingly common because of the popularity of things like React.
Okay.
So React uses, you're always passing JSON back and forth. And as you get these sort of single page applications, the server's job is really just to spit out this kind of stuff. And REST is one of the more popular ways of doing it. So it's even if you're web coding, this is becoming a more common thing to understand, and better written APIs make it easier for people to consume them and more likely to want to use your code.
Yeah, that takes us into projects, and I guess I'll start. Mine is really simple. It's taking a library that we probably mentioned more than any other library on the show, which is Black, and it's called blacken-docs. And the idea is that it's going to run, code formatting, this Black formatter, but on documentation files. So if you've done additional documentation, maybe it's in Markdown or some other kinds of files, and you've highlighted the code or have code within it, it can actually go into that. It supports a handful of different formats. I can list off some of them. Everything from Markdown, RST, LaTeX, which is spelled LATEX, or some kind of combination of Markdown with RST and Python doc strings. It's pretty much does what it says on the tin. It's by Anthony Sutile, and he's probably most famous from his stuff of Code with Anthony, and he works on a lot of different projects. So I think one of those might have been scratching his own itch of looking at documentation and wanting to add it to it. So yeah, if you have some Markdown docs, we have a particular tool that we've been using for doing slides, and it's all in Markdown. And so this might be a nice way to kind of have it go and check out those code blocks that we're doing inside of our slide system. So blacken-docs.
Yeah, one of the things I like about this one is it supports the blackening of doc tests.
Yeah.
So if you're writing tests inside of your doc strings, and then you've got the kit that actually runs those tests from the doc strings, now you can run this and put black on that code that's embedded in your doc string. So there's 3 layers of indirection there, but it allows you to clean up code that is otherwise a comment, which is nice.
Yeah, cool. So what was your project?
Yeah, so I'm highlighting something called asciimatics by Peter Britton. So full disclosure, I've contributed to this one, so I've got some bias.
All right.
It's a TUI, that's a text user interface toolkit. And as it says in the description, it brings a little joy to anyone who was programming in the 80s, which I was. So it's got decent support for your typical TUI stuff with like forms and mouse events and all that kind of thing. Your usual UI things that you want inside of a TUI, but it's also got this concept of animated scenes, and this can allow you to get pretty creative. So to give you just a quick idea, I'm just going to list off some of the sample files, the names of them in the library, and you can get an idea of what you might be able to do. So there's bar graph, fire, fireworks, fruit, grumpy cat, kaleidoscope, Pac-Man, and Christmas.
There you go.
So it's got that whole 80s demo vibe going on with your ASCII characters. So there's some fun things in here to play around with on your terminal. So I've used this with a couple of my own projects now. I'm typically just using the form management stuff, text fields, buttons, mouse events, that kind of thing. But there's a lot of other stuff being here as well. But the other reason I kind of wanted to highlight this is beyond just being fun, it's also a pretty good example of a good open source project. So the documentation is comprehensive. Peter is fantastic from a support perspective. He's got a forum that he's very responsive on, just helping people use the library. And he's keenly takes PRs. He's got a nice little credit script in there. And I think there's like a dozen different people who've contributed over the years. The only thing is he's a bit of a stickler for good unit tests, but that's probably a good thing. That keeps a positive thing and keeps the library in a good shape, right? So yeah, it's nicely written code and fun to play with. And I do a fair amount of like one-off TUI type things for my own tools, internal use when I'm recording courses and that kind of thing. And I find I used to do a lot inside of Erwood, and I much prefer asciimatics. I find it far easier to use and get something going very quickly. So fun little thing.
Yeah, I'm looking at the GitHub repo and I see your little face there.
Yeah.
Not only in the use by, but as a contributor. So that's great.
Yeah, well, I actually just committed something a couple days ago. It was like a one-line change, but I found something that scratched a particular itch I had, and it was like, oh, if I just change this one little thing, and
cool.
And I submitted it, and he immediately said, "You didn't include your unit test." I'm like, "Yep, you're right." And so I went and put the unit test in.
There you go.
So yeah, 3 commits later, my one-line change was allowed in. So
all right, well, congratulations. All right, well, that wraps it up for this week. Thanks again for coming on the show. It's been a fun talk.
Cheers.
Remember, you can create and deploy web apps with Python and nothing but Python using Anvil. Try it for free at anvil.works. I want to thank Christopher Trudeau for coming on the show this week. And I want to thank you for listening to the EuroPython podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the EuroPython podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.